Let's continue with our Fluid Helper class. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. At the end of the previous video, we did handle the isEmpty and transferring the fluid between a container and the storage. In this video, I want to write a method that will check if any slot can accept something that may contain a fluid or an empty fluid container. So we say public static that returns a boolean is valid slot. Here what we want is an inventory, we call it inventory, and the slot, and then I can accept a fluid variant, but that doesn't make sense, so I will go with item stack. The idea here is that we will try to put an empty bucket inside a slot, or another example is a fluid bottle. So we have an item stack and we want to put it inside this slot and we want to see if it's valid or not. Now this can become confusing really fast, so instead of starting with a code, we need to sit back and think. First things first, I want to get the stack inside the slot, so I will say stack or slot stack, because we have item stack, equals to inventory.get stack slot. I will bypass the ability to check if the slot is actually the predicate slot, because this should happen inside block entity. I assume that any empty slot can accept anything. So I will say if the slot stack is empty, then immediately I return true. I can accept anything. Other than this, as I said, things can become really confusing really fast. So instead of code, we'll start with talking in English. The very first thing we want to check is that is the output item is the same item we are trying to send in. If not, return false. So let's put an example here. Let's say that the item stack here is a water bucket, and what we are sending here is a bottle of water. This should fail because a bucket is not a bottle. Then we should check is the variant between the two items are the same. An example of it is that we have a water bucket, but we want to send in lava bucket. Both of them are buckets, but one of them contains water, one of them contains lava. Also, if we want to send in an empty bucket, when we have water bucket, it will fail because the variants are not the same. Then we want to check is the amount between the two are the same. Now this one has no example in vanilla, because if they are the same item and if they have the same variant, then the amount will eventually be correct. However, in a mod, for example, you may have an item like, I don't know, maybe some capsule that can has water in it, so water capsule, that can accept up to, I don't know, 10,000 millibuckets. And what we are sending in is that a water capsule that has 1,000 millibuckets in it. The item is the same, the variant is the same, but the amount is not the same. So we can't put them inside one stack and it should eventually fail. If everything is met, then we are sure that we are the same item, we are the same variant, we are the same amount. So at the end, we already can return true. Problem: when we are working with items, we don't have single fluid storage or single variant fluid storage. We are dealing with the storage of variant both on the item stack and on this slot stack. So we will have two loops inside each other. Because of that, this first one is easy actually. We can say if the slot stack dot equals, and it says its object, I don't want that, dot is of the item stack dot get item. If they are not the same, then we will fail. That's the first one. Then we want to have two variant storages. So storage of fluid variant, and we call this one the item storage. It's just the same thing, container, item context with constant for the item stack. Then we will have a duplicate of this guy, but this one will be slot storage, and instead of using it on item stack, we will use it on a slot stack. Okay, now that we have these two, we need to do a for loop. And as I said, we need to make sure that we loop 2 times. So we will have a boolean flag that is true, and at the end I will return that flag, because if we hit here, we are sure that the amount and the variant is correct. So we will start looping inside one of these, and we already have this loop from previous videos. It's this guy. Now it doesn't matter which one we will start with. This is a slot view. I will copy this one and let me close that so that I know what I'm doing. I will have another one, but here we will go with item view, item storage, and I will call it item view. Now we can check these two conditions. Actually, I need two flags here. So I will say variant flag equals false, and then Boolean item flag equals false. And then here I will say variant flag and item flag. So for variant flag, if the slot view dot get resource is equals to item dot get resource, we will say variant flag equals to true. I need to check something else because I was trying to early exit here. If I want to do early exit, then I will have another set of for loops, and it's not optimized in any shape or any form. So if the variant flag is already true, it doesn't matter if we reset it back to true. Here we will say if the slot view dot get amount is equals to the item view dot get amount, then item flag is equals to. And as I said, I'm not going to early exit. Now here's an example. If these capsules can have two different things. For example, a capsule that contains water for 10,000 and lava for 500, and we are trying to send in 1,000 of water, we are starting with the slot. And this is this guy. Let's say that we start with water. That's okay. And we go for this guy. Okay, the capsule is 1,000, the water is 10,000. Let's say that this is 10,000 so that it will be equal. Then the variant is the same, the item flag is the same. We will continue. The next iteration, we have lava on this top layer. So slot view will be lava. It will not be equal to the item view. However, we have already set this flag to true. So we don't care. I can optimize it a little bit. I can say if a slot view dot is resource blank, then we continue. So if it's blank, then please continue. We don't want to do with anything. Other than that, if the item view is blank, we can't compare a blank to something that is there. So again, if item view that is blank, we want to continue. This means that the second iteration, we have this lava for the slot view. So we will fall here, but then we will have nothing here. It will fail and it will continue for the next iteration, and then it will empty out. And that would be it. I think so. Now, what is it saying here? I think it says assert a slot. We need to check that. So if the item storage equals null or the slot storage equals null, we return. Should I fail here? Yeah, because we have an item there. We made sure that we have an item there, and we made sure that we have an item that is the same thing. So if the storages are failing, then something is seriously wrong there. We return false. If the item stack that we want to send in is empty, then we will fail. We won't do anything else. That is that. So we can't send air around, for example. Any other conditions? Let me think. So we made sure that the item stack is valid, the slot stack is empty, or then we check for the validation. We check that both of them are the same item. Then we go for the variant and the amount. We make sure that we have both the same variant and the same amount. This looks correct to me. So let's give you an example. Let's deal with this logic because it's a very complex thing here. Let's say that we have empty bucket there and we want to send in some item stack. We are not sure what the item stack is. So the item stack is not empty. The slot already has a bucket empty. Now, if we are not empty bucket, we will return. That's okay. We are sending in the bucket, empty bucket. So here, the variant in both cases, here's the thing. What is the variant for an empty bucket? I think we have a variant of empty fluid variant dot or fluids dot empty. Yeah, we have empty fluid. Okay, so it can cover that. I think a bucket will carry empty fluid. Then both of them having the same variant being fluids dot empty, and then the amount of 0. So it should work. Fingers crossed. So I will remove these notes and hopefully we have a correct method there. Now, my original notes was something totally different. Here, I was assuming that I'm working with bucket, nothing else. And I would assume that I want either an empty bucket or not an empty bucket. So I was checking if I should be an empty bucket, then I'm checking if it's empty bucket item. If I'm not empty bucket and I shouldn't be empty bucket, then I would get the resource to be the same and the count to be less than the count. Now, this is something that I need to check. So if the item stacks are exactly the same, then we should check if the slot stack dot get count is less than slot stack dot get max count plus that. It's the other way around. So if the amount that we have and the amount that we are sending in will end up to be empty, or it will be less than or equal, so we will negate that one to be greater, then we return false. So we can't accept extra. An example of this is that we have 16 buckets on the output and we want to send in another same bucket there. Up until now, the buckets are not empty and they are the same thing, but we can't accept any more item. We are already full on the output slot, so we don't even need to do these checks, okay? It's a little bit of optimization there, and it's a needed check, so that will solve that one. That should be it. I can do a little helper method here that says is empty bucket. It's really a small thing, but every small piece of helper method is good. So empty bucket for the inventory and int slot. All we are doing here, we are returning the inventory dot get the stack in the slot. It should be is of items dot bucket, and it will return a boolean. Then we want to simulate things for insertion and extraction. As you know, transaction happens in two steps. One is simulating and then committing. Here we will say public static that returns a long simulate insertion. All we want here is a storage of fluid variant. This will be a storage. Then we want a fluid variant that we want to simulate variant. And then we want to simulate some amount. Actually, do I want the amount? No. Do I want a transaction there? Not really, because all we want to see is how much we could insert. Here we say long amount equals to 0. Then we say try a transaction being the outer, or I don't know, maybe inner. I don't care. Let's go with, why not using nested? Because, oh, here we need a transaction. Okay, I will have two variants for this because sometimes you are using it inside another transaction. So instead of null, here we need the, let's call it outer. So this one will be outer.nested. Basically, we are doing it inside another transaction, and open nested now works. And we will say long. Actually, we have the amount, so amount equals to storage.insert, and we use the long.max. It will tell us anything that we have. And then finally, we want to abort the transaction, so transaction.abort. Although it will abort itself at the end, we return the amount. Now I will have another overload of this whole thing, and I can't call it self, but this time we are not doing this simulation inside another transaction. So instead, we will say transaction equals to transaction open outer, and it will work. The first overload will be used when you are trying to simulate inside another transaction, but this overload will happen when you don't have any transaction and you just want to simulate and see what is the result. I will have another one, and that is extract. So I will copy these two, and I will call this one simulate extraction. Instead of insert this time, we go with extract, and that's the whole thing. Then we want to see if we are the same fluid tank. Now I'm going from my notes, and let me check what we are doing here. We are checking the storage fluid. Here we are accepting a single variant of storage. And this is, by the way, totally wrong. We shouldn't do this because I'm just getting the first iterator. That's totally wrong there. However, if we want to make sure that we are doing it correctly, we'll say public static boolean same fluid in storage, and then we want the inventory called inventory, the slot, not that, the int slot, and then just the storage, so we don't care about the variant, same fluid in the storage. So we have an item inside some slot, and we want to see if we have anything inside the storage or not. First things first, we want this slot storage, and we want the slot, so let's just copy paste it. Before I go forward, if the slot stack is empty, return false. That's something that we need to check. If the slot storage is null, again, return false. We want to loop through both of them. Do we have size on the slot storage? No, for God's sake. Okay, here's the problem. Our slot can have a capsule of two different things, and we want to make sure both of them are inside our storage. So the moment that we found something inside the slot that is not in the storage, we can do early exit. So let's write it down. If we have something in slot that is not in the tank, we return false. Otherwise, we will check everything and at the end we will return true. So we want to have a flag Boolean flag equals to true. At the end, we will return the flag. Now again, we will have two loops like so. And let me close these so that I'm not messing things up. And here we will have, instead of item, we have the storage. And this is the storage view. So if the item view is blank, then continue. If the storage view is the blank, continue. If we have something in the slot view, so slot view that get resource, no, it will not work. Yeah, it will not work unless I accept a fluid variant instead of item slot, because I don't have any way of getting my hand on the number of slot views that we have in the storage. And unfortunately, the iterator does not return count. And I don't want to iterate once and just get the count. That's stupid. Honestly, this sort of stuff is really hard to handle. So let's think about it. We have unknown number of slot views in the storage. We have unknown number of slot views inside our tank. And we want to make sure that we have everything here that is here. Well, I had seen 30 have something close to this, but for recipes, let me see if I can find that mixer recipe thing. So it's not in block entity, it's inside recipe, mixer recipe. He's trying to do something close to this on the get match. And basically he knows that he has some number of inventory slots and some number on the ingredients, okay, some number of inputs and some number on the recipe. So he is making a list of remaining ingredients. And where is he using it? It's inside here. Present items are the things that is inside his inventory. He has a loop that goes into each item stack, streams them, filters something that should be filtered, gets the first if present or else. If present, it adds it to a stack, and then get a stack in a slot, then filter item stack is of the item, find first. This is even more confusing for me. We want to make sure that everything that we have here is containing here. Okay, let's add a boolean here that we say found equals false. Then we loop through everything. If they are correct, here's a problem. I can set the found here, okay, found equals to true. This will work for the very first iteration. Let's give ourselves an example of a capsule with lava and water, and this is inside the slot, and we have another capsule of lava, water, and I don't know, maybe something, and this is our container. In first iteration, we go for lava. So here we are in lava case. If we found lava in here, well, we found lava, so we set the found to true. Here we can say if not found. So if we didn't find our first item in here, then we immediately return false. That's okay. Then we go for the next one, water, and let's say that we have, I don't know, something number 2. Then we go for the water. Again, we have the water, so this condition will fail. We'll continue. Then we have something number 2. At the start, we set it to be false. We don't find it, then we early exit. This will work. We don't need this flag. At the end, we assume that we didn't find anything else. We should return true here because we had looped through everything. And for example, we have looped through something and the something is the same. We will not fall here. We will fall here. And we have all the early exits possible. So at the end, we are true. This will work, yeah, because we are doing early exit. If, I don't know, this is something number 2 at any point, it will not find it there and it will false. Okay, looked confusing, but it's not. When you put some examples as code, it's not that confusing, isn't it? Now, because we are using the storage, it will work with simple variant storage, anything else. This is the most generic thing possible. Now, instead of this, I can go with 2 storages and basically they will work. This is a storage 2. This is a storage 1. Now, the same code should happen, and actually I will call this one later. It will go from here to here. This will be a storage 1. This one will be a storage 2. And I just need to check if a storage 1 is null or the storage 2 is null, then return false. Thankfully, instead of all this mumbo jumbo now, I can simply return same fluid in storage, and I will send the slot storage and the storage. Now we want to see if the tank is full or not. A full tank means that each one of its fluid variants amount is greater or equal to the capacity. So we say public static boolean is storage full. Here we want the storage. We simply check if the storage is null, return false. Actually, I will return true because we don't want to deal with anything there. Then we want to loop through the storage the moment we find something. So if the storage view, let me do this. Yeah, we want to go over the blanks. So if the slot view dot is blank, is resource blank, should we return true here or should we continue? Because we want to see if we are full or not. If we have an empty or blank resource, then we are not full, so we return false. Other than that, we check if the slot view dot get amount is greater than or equal to slot view dot get capacity, or actually I should negate it. If it's smaller than the get capacity, then we return false. At the very end, we return true because we checked everything and they are all greater or equal to the capacity, so they are full. And this is a storage full. Public static boolean has capacity for or something else. Yeah, can accept. Should I just go with the amount or no, just can accept. Here I want a fluid variant. Let's go with a fluid stack. Why I'm not doing that? Fluid stack payload, I will say stack a storage of fluid variant and we call it the storage. Now here we simply check if the storage is null. We return false, not true. Then we say if the storage dot, actually we need to try a transaction. So try transaction open outer. So we say if the storage dot insert, the variant comes from the stack dot, come on, fluid stack has a variant, isn't it? Fluid, then we try to do the long and we return it. Return the amount that we sent the inside the stack. So stack dot amount is smaller or equal to the amount that the storage can insert, because it may be able to insert 10 buckets and we are wanting to send 1 bucket. Yes, that's it. So we just return, and at any exception it will just throw anything. So that would be it. But let me do this. Long amount equals to the transactions result. So if the stack amount is less than amount and amount is greater than 0, so we can even put things there, then we can accept that fluid. Now here is something that I have, and it will show its face when we are working with pipes. Static that returns a storage of fluid variant, and we call it get storage, but we use word and block pause and then a set of block pause as the blacklist and then a direction. Let me move this direction before the set. What we want is that we are looking at a direction, and inside the word we want to see if we can have any storage fluid there or not. That is not a special block position or a list of block positions. So we say block pause equals to the pause.offset in the direction. Let's call this one adjacent pause. Then we say if not, the exceptions, or here is blacklist. If the blacklist does not equal null and the blacklist contains the adjacent pause, return null. Otherwise, we return fluid storage dot sided dot find in the word with adjacent pause on the direction but the opposite, get opposite. This means that, for example, we want to see if we have a block on top of ourselves that contains a fluid storage. The position is our position. The direction is up because we want to look on the top. So we say that, hey, find the block that is on top of ourselves, and if it has any storage that can accept from bottom, then we return that storage. And this is the whole thing. So another one is public static that will return a list of storage of fluid variant. Here we call it get all storages inside a word, block pause, but we are not setting any direction here. We will create a list of storage variant, storage of fluid variant storages, and then we want to loop through all the directions. So we say direction.values.for. So for each direction, we will try to find adjacent pause again. Then if the adjacent pause is inside blacklist, instead of returning, we just continue, and I will fix those errors later. Then we want the storage. We call the storage of fluid variant storage equals to that. If the storage does not equal null, we want to say storages.add storage. Now what is the problem here? The pause is there, blacklist is there, the word is there. Let's finish this. Return storages. Now, why are you yelling at me? Oh, a semicolon there. Derpy. Okay, so this one is helpful when we are a cable, for example, or a pipe in this case. A pipe will look on all the blocks adjacent to itself and collect every possible storage that is not something. The reason is that, let's say that we have two pipes. This is one pipe and the green one is another pipe. This first pipe is telling this pipe that, hey, update yourself for whatever reason. But at the same time, it is saying that, hey, I'm on your blacklist. I'm the sender. So when this green pipe is looking around itself to find another pipe to push things forward, like the light blue one, it will ignore this one because it was the sender that already filled this one. So it shouldn't send back any amount of fluid. Now, this will become a little bit confusing in the code right now, but when we deal with this, it will not be as confused as you think. This is the reason we have those blacklists, because a push-based system has this problem. Things go back and forth in the pipes, and we want to make sure that we won't go back, and those backs will sit in the blacklist. I can have a method for converting to millibucket and back from millibucket. Honestly, I will avoid it because my fluid widget is handling everything. Then we have this single one that is interesting. Public void spread. Now we want to spread fluids around. We will have a block entity called block entity, a word. Actually, we can get the word and position from the block entity. So a set of block pause that is blacklist, and then a storage of fluid variant called storage. Let me check my notes and see where I'm using this equal amount. Oh yeah, I understand. Okay, a boolean that is equal amount. Now the idea here is again the pipes. A pipe may have some adjacent pipes. Let's draw them. So this is the block entity. It will look around itself first, and it will find 4 different pipes that can accept the fluid. The idea behind this equal amount is that it should distribute its content equally between all 4 of these. For example, if this container, the blue container, has 1,000, and we are saying that we want equal amount, each one of them should get 250. If we are not setting it, it will find the very first in the list and try to push all the 1,000 there. If there is something remaining, then it will try the next, then it will try the next. So here we want to have the loop on the storage, so let's get that. And we have the view, let's call this one storage view, why not? In each one of these iterations, we will have many things, so I will just take them out. We want a fluid variant, we call it variant. We want a block pause, we call it adjacent pause. We want a storage of fluid variant, and we call it not a storage one, actually we call it adjacent storage. And I'm taking them out of the for loop because I don't want to recreate them all over and over and over. We will have a list of fluid variants, we call them storages. Let's call them adjacent storages. Anything else from my notes? No. The very first thing that we want is that we want to get the variant. So we say the variant is equals to the storage view dot get resource. After that, actually even before anything else, adjacent storages. Now we have this that gets all the storages around ourselves. We say equals to get all the storages from block entity dot get word, and then block entity dot get pause and the blacklist. So we collected everything around ourselves. I think I did something else here. Let me see. I'm moving inside all directions, getting the adjacent block, and then if it's blacklisted, then continue. Then I will get every fluid resource on that direction. This will return a storage. That's okay, because this part is totally wrong again. I'm just picking up the very first thing from the thing. We add it to the storage, the fluid storage. I'm adding it to the storages. Instead of this, I'm just doing it there. So this is a single line of code. Here we say if, actually before this even, before anything else, I can say if adjacent storages dot is empty, means that we didn't find anything, we return. The beautiful thing starts. We want 2 more loops. So we say adjacent storages dot for each adjacent storage goes into. So we are looping through, actually I need to remove that one. Okay, we loop into everything that we have in the list, and then we want another loop through adjacent storage, and we call it adjacent view, and we will try a transaction, but I will do that try on top. I will try a transaction that is outer. We want to see how much we already have. We should do it before the second for each loop. When we got the variant, we can accept these out of the loop. So we have a long current amount, and then we have a long total extractable, then we have a long total insertable, and then a long final amount. I will just say them to be 0 to begin with. Here we will say that current amount equals to the storage view that we have dot get the amount, I think. Oh, storage view dot get amount. So this is the amount that we already have. Then we want to see how much we can extract. So total extractable equals to the storage itself dot extract the resource that we have, the variant, and the max value that is possible using the transaction. Final amount equals to the number of things that we have in the list. So if it's equal amount, then we want to divide the total extractable by the adjacent storages, that size. Otherwise, we want the total extractable. So now inside here, we want to see if we can insert into any one of these. Actually, I don't need that internal loop now. So we say that adjacent storage should accept it. So we say the total insertable equals to simulate insertion that uses the transaction for the storage that we have. Here is the adjacent storage. Then the variant is the variant that we want. Finally, transaction that we have is transaction. This is the one that is using the inner, okay? Now, what's wrong with you? Fluid variant and inner, it will return a long. So two problems here. It says copy variant to effectively final temp variable. No. Convert to atomic. Why do I need to convert it to atomic? Oh, well, we will figure things out. Actually, I think I will do this. Let's remove that because my notes has nothing to do with atomics. So long, 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 and the variant, god damn it. Okay. Be happy now. See, they need to sit inside the loop. Stupid thing. But then we got the total insertable. Now we say long inserted equals to the adjacent and insert, not the max value here. We have that final amount that we can use here. Honestly, current amount, I think we will use it here. Let me see. Where am I using that current amount? No. We will use it below, okay? Then we will have, let's call it insertable. Then we will say total insertable plus equals to inserted, okay? And we need that one, so we will say a long total insertable equals to 0 at the start. Why? I don't want to convert to atomic. Now, let me see what I'm doing here. We will say if total insertable or inserted is less than total extractable, so we inserted less than the amount that we want to insert, or it's actually equal, so smaller or equal, then we want to do the thing. So storage.insert the variant with not the max value, but the total extractable. This shouldn't be the case. I don't need to do the simulation at all. I don't need to do this at all. All I need to do here is that, actually, you know what? I need to do that transaction thing here. So that's the try, because if the inserted is actually the same final amount that we want to insert, then we want to make the transaction to commit, okay? Other than that, we will else, just in case, we abort the transaction. So we loop to each one of these adjacent blocks, adjacent storages actually, and then we try to insert the amount that we should do there. Here I need a transaction. Yeah, I need to do that. Actually, extract. This can be a simulation because right now we are not doing anything. Let me pause the video and I will come back when I'm done with this. Okay, I had to pause the video and a little bit think about the solution, but the solution was there, just needed a little bit of tweaking. So instead of using for each the way we had for this internal loop, now I just use a normal for each loop. The only thing that is changing is that when we insert, we make sure that the inserted amount that we have is just the final amount that we want to insert. If that is correct, we will commit the transaction, and now we have this total inserted that we will add to it. If this fails, then we abort the transaction and we continue the loop. When we are finished here, we had done everything that we could with our adjacent storages for this single storage view. Then we will check if the total inserted is greater than 0. In other words, if we inserted anything at all, then we want another transaction and say that, hey, from the storage, please extract the variant we have with the inserted amount and the transaction and commit it. Basically, we are saying that we have a storage view inside the storage. We will look everywhere and we extract as much as we can. Then we will reduce the amount that we extracted from the same storage that we are working on. And then we will check if the current amount in the storage is not equal to the one that we had at the start of this whole loop. We will update the block entity, and if the block entity is not updatable, then mark it dirty, and then we will continue the bigger loop and go for the next view in our current storage in the central position. Because remember, we had that cable at the center and we have 4 different pipes around it, for example. This will handle one type of fluid inside the central pipe for the all adjacent ones, and then goes for the next on the center and do the whole thing again and again until we are done with our central pipe. And at that time, we had done everything we can and we exit this method. I want few overloads for this. One that will not accept the total amount and will accept only a storage and blacklist, and the other one that does not have any blacklist but is accepting the total amount, and finally one that is not accepting a total amount and is not accepting any blacklist. Now these we'll call the other ones the main ones. So we call the spread for the block entity. We have the blacklist, and for the equal amount, actually we'll say true. By default, we always want to send equal amount around ourselves. This second overload we call the spread with the block entity. Then we have to send in the blacklist. Well, I will take this blacklist from here and move it to the end because it's a set and it will take multiple lines maybe. So here I have to cut it and paste it to the end. Now we don't have any blacklist, but we have the storage. So storage and equal amount, and for the blacklist we send null. And here we just send true and null for our blacklist. Although I can just call the top overload, but I will prevent going into this method and then jumping out, preventing one extra method called there. If we call this overload, for example, it means that we don't have any blacklist and we want to spread equally around ourselves. That being done, our fluid helper class is finished. And if we go back here, all that is remaining is importing this class and it will work. And finally, our JiFluid library is complete. Funny fact is that the energy library will look close to what we have for the fluid. However, it's easier because in fluid helper, for example, when we want to do a spread or get the amount, get the resource, we have to deal with the views and the storages and everything like that. Guess what? In energy, things become much simpler and much more straightforward. However, for the energy, I may not use the J inventory. And because of that, I will keep the energy the way it is. In the next video, we will come back and work on our G energy library.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.